I made an error in class that I want to correct here. In class, someone asked me about finding the area bounded between the curves. This is r squared equals 50 sine 2 theta, and r equals 5. So this is actually just a circle, but it's just the part that we care about. And what we did in class is we found this red area here, or what I thought was this red area here, by looking at the integral. So what we did in class is we took twice the area because it's this part, and over here you would have a symmetric piece. Okay, so those would be the same area. And so we doubled our answer. And I found this integral in class. It was 1/2 the integral. We found in class that these two curves intersect at angles 5 pi over 12 and pi over 12. Let me get our bounds right here. So those are the bounds. And then I said that the area that we were looking for was the area of r squared, the outer curve squared, so 50 sine 2 theta, minus the inner curve squared, which is 25. So notice that they already give us r squared here, so we don't have to square anything. And then we did the work, and we found that this was 25 times square root of 3 minus pi over 3. The problem, and we did some steps here. Let me scroll just to make sure that my memory serves me here. But the problem, I want to make sure I get the exact number right here. Yeah, 25 square root of 3 minus pi over 3. Good. So the problem was that that's not actually the area that we found. What we found is not the area that we were looking for. What we found was actually this green area. Okay, because that's the outer curve minus the inner curve. So we really found that green area there. And what we're looking for is the red area. Now we can solve this problem by finding the area enclosed by this orange curve here. So we can find that. And if we take that whole orange area, subtract from it the green area, what we'll be left with is exactly what we want, which is the red area here. So we'll do that now. So let's find the area enclosed in one of these leaves here. And then again, I'll double it because by symmetry, we're looking for this area plus this area. So let's double it. And then the area is going to be 1/2 the integral. We're going to have 50 sine 2 theta. And then that's our r squared already. And then notice this goes from r equals, from theta equals 0 to theta equals pi over 2. Because at pi over 2, it's going to come back to 0. Right? If you plug in pi over 2 here, you'll get r equals 0 again. This will go from 0 to pi over 2 d theta. And so the 2 and the 1/2 cancel. The 50 we can bring out. So this is 50 times the integral of sine of 2 theta from 0 to pi over 2. And so that's going to end up being 50 times negative 1/2 cosine 2 theta, evaluated from 0 to pi over 2. And when we plug in, so that's a negative 25, we can factor out now. And we're going to get cosine of 2 times pi over 2, so that's pi, minus cosine of 0. So that's negative 25 times negative 1 minus 1, or negative 2. So altogether, the area here is 50 exactly. There we go. So the area of this entire petal is 50. And then if we subtract the green area, which is what we found here, that'll give us the red area. Okay, so that gives us the red area. So the red area, the area that we're looking for, is going to be the orange area, which was 50, minus the green area, which was 25 times square root of 3 minus pi over 3. And so if we do this out, you'll end up with 50 minus 25 square root of 3 plus 25 pi over 3. Okay, so I made the mistake of calculating the wrong area in class, and this is how we fix it. Okay, and again, this was the area bounded between the two curves, r equals 5 and r squared equals 50 sine of 2 theta.